Hello everyone. In this video we'll discuss indices, laws of indices and numericals based on indices. Let us define indices. In order to understand this, let's take one example. If a number 3 is multiplied by itself 6 times, that is 3 into 3 into 3 into 3 into 3 into 3. That is 3 is multiplied by itself 6 times. We can represent like this, or we can also represent the same 3 multiplied by itself by using indices as 3 to the power of 6, right? Here 3 is called base and 6 is called exponent, or we can also see it as power. So that means when a number is multiplied by itself, we'll represent by using index. In general, if a number a is multiplied by itself n number of times, like this, a into a n times, then we will represent it as a to the power of n. Here a is called base and n is called exponent, or we can also say it as power. Now let's discuss different laws of indices. Let us list out laws of exponents which will be useful to solve many numericals. The first one is a to the power of m into a to the power of n is equals to a to the power of m plus n. That means when the bases are same, we can add the powers, right? So let's consider one example. If it is 5 to the power of 100 into 5 to the power of 150. So this will be equals to 5 to the power of 100 plus 150, which is nothing but 250. That means when the bases are same, we can add the powers. The second law is when the bases are same and it is in the form of division, we can subtract the powers. Let's take one example. 6 to the power of 250 divided by 6 to the power of 100. So this will be equals to 6 to the power of 250 minus 100, or we can write it as 6 to the power of 150, right? The third law is a to the power of minus m is equals to 1 by a to the power of m. That is, when the exponent is negative, we can represent it as a positive exponent by dividing it with 1. Let's take one example. If it is 2 to the power of minus 3. So this value we can calculate if we represent it as 1 by 2 to the power of 3, which is nothing but 1 by 8, right? Now let's see some more laws. The fourth law says that when a number has two powers, we can multiply those two powers. That is, a to the power of m to the power n is equals to a to the power of m into n. Let's consider one example. If it is 2 to the power of 5, this whole power 10. So this will be equals to 2 to the power of 5 into 10, that is nothing but 50. Let's take one more example. If it is 3 to the power of 5 to the whole power 1 by 15. So this will be equals to 3 to the power of 5 into 1 by 15. So we can cancel out this. So it will be 3 to the power of 1 by 3, or we can represent it as cubic root of 3, right? So this is second example. According to fifth law, when the bases are same, we can equate the powers. That is, a to the power of x is equals to a to the power of y, then x is equals to y. So let's take one example. If it is 2 to the power of x plus 3 is equals to 2 to the power of 5. Then in order to find out this x value, we can equate the powers. That is, x plus 3 is equals to 5. That is equals to x is equals to 5 minus 3, which is nothing but 2, right? So 5 minus 3, that is equals to 2. One more law is when the powers are same, we can equate the bases. That is, x to the power of a is equals to y to the power of a, then x is equals to y. Let's take one example. If it is 2 by 3 square is equals to x by y square. Then to calculate x by y, we can equate the bases as the powers are same. That means x by y is equals to 2 by 3, right? Let's solve the questions based on the laws which we have discussed. Let's solve the first question. The value of 125 divided by 216 to the power 1 by 3. As we know that from the laws of exponent, this exponent is applicable for both the numbers, right? So let us represent that 125 to the power 1 by 3 divided by 216 to the power 1 by 3. Let's try to represent the numbers, that is 125 and 216, in terms of a number powers of 3, so that we can cancel out the number power and this exponent, right? As you know that 125 is 5 cube, this whole power 1 by 3 divided by 216 is 6 cube to the power 1 by 3. So this will be equals to, from the laws of exponent, we can multiply both the powers, that is 3 into 1 by 3, and here 6 power 3 into 1 by 3. Cancel out 3, 3, 3 and 3. So that will be equals to 5 by 6, right? Look into the second question. If you observe here, the bases are same. So from the laws of exponent, we can add the powers. So that is x to the power of p minus q plus q minus r plus r minus p. So this will be equals to, if you observe, we can cancel out minus q minus r plus r minus p and plus p. That means it is x to the power of 0. It's nothing but 1, right? So this is a solution 1 and this is a solution 2. Let's solve the third question. The value of 1 by 216 to the power minus 2 by 3 plus 1 by 256 to the power minus 3 by 4 plus 1 by 32 to the power minus 1 by 5. Let's take the first term, that is 1 by 216 to the power minus 2 by 3. So this will be equals to 1 by, as you know that 216 is 6 cube into minus 2 by 3, right? Here we can cancel out 3 and 3. So it's nothing but 1 by 6 to the power of minus 2. Or we can write it as 6 square, that is 36. Let's name this as 1. Now take the second term, 1 by 256 to the power minus 3 by 4. So this is equals to 1 by 256, we can write it as 4 to the power 4 into minus 3 by 4. Here we can cancel out 4 and 4. So this will be equals to 1 by 4 to the power of minus 3, or we can write it as 4 cube, that is equals to 64. Now let's name this as 2, right? The third term is 1 by 32 to the whole power minus 1 by 5. This is equals to, as we know that 32 is nothing but 2 to the power of 5 into minus 1 by 5. So cancel out 5 and 5. That is 1 by 2 to the power of minus 1, or we can write it as 2. 2 to the power of 1, that is equals to 2. Let's name this as 3. According to the question, add 1, 2 and 3. That is 1 plus 2 plus 3. So that is equals to 36 plus 64 plus 2, which is nothing but 102, right? So the answer is A. Let's look into the fourth question. The value of 5 to the power of 1 by 4 into 125 to the power 0.25. In order to solve this question, let's try to represent 125 in terms of 5, so that the basis of 5 to the power of 1 by 4 and this term will be same. Then we can add the powers, right? So let's do that. That is 5 to the power of 1 by 4 into 125. We can write it as 5 cube to the power 0.25. Let's simplify this 0.25. So 0.25 we can write it as 25 divided by 100, right? By taking out decimal point, we can write 25 by 100. Now we can cancel out this. So that will be equals to 1 by 4. Now let's substitute over here. That is 5 to the power of 1 by 4 into 5 cube to the power 1 by 4. So this will be equals to 5 to the power of 1 by 4 into 5 to the power of 3 by 4. Now if you observe, the bases are same. So we can add the powers, that is 1 by 4 plus 3 by 4. That is equals to 4 by 4, or we can write it as 5, right? So the answer is B. In next session, we'll discuss some more questions based on indices. Thank you for listening and have a good day.